The olive tree is not a plant. It is a statement of intent. Wherever Rome reached, the olive tree arrived, not as an accidental crop, not as a seed that traveled on the sole of a legionary's sandal, as a policy, as a project, as the visible mark that a territory had changed hands and that its inhabitants were being incorporated into a new order that had a specific flavor, a specific color, and a specific smell, the green and slightly bitter smell of oil freshly pressed on a millstone. And where Rome arrived first, Spain arrived later, with the same tree, with the same logic, with consequences that, on the American continent, were so profound and so silent that even today, most people living between the Rio Grande and Patagonia don't know that the most peaceful tree in the world was, in the 16th century, an instrument of deliberate destruction of the local medicine of two continents. This is the story of the olive tree. Not a story of condemnation, the olive tree is, as we shall see, an extraordinary plant whose modern pharmacology is yielding some of the most unexpected findings in contemporary herbal medicine. Rather, it is a story of how a plant can become a vector of colonization, of how what is planted in a territory dictates who rules that territory, of how botany has always been, ever since human beings began moving seeds across the globe, a way of exerting power over the bodies and memories of others. Can a plant be colonialist? The question seems absurd. Plants have no intentions. They don't plan. They don't conspire. But the people who carry them around do. And understanding what they did with the olive tree is to understand something about the power that botany has when it is put at the service of domination. To understand what happened in America, we must begin in the Mediterranean. We must begin with a tree that has 15 million years of evolutionary history in the Mediterranean basin, and with the civilizations that learned to read it as a text that spoke of time, of the earth, and of the gods. The wild olive tree, the oleaster, which botanists call Olea europaea in its sylvestris variety, has been in the Mediterranean basin since before humans existed. Fossil records of olive leaves found in Miocene deposits in Italy and North Africa place the presence of the genus Olea in the Mediterranean approximately 15 million years ago. When the first hominins arrived in that basin, the olive tree was already there. They found it growing on the rocky slopes of what are now Greece, Turkey, Syria, Lebanon, Israel, Egypt, Tunisia, Algeria, and Morocco. And almost immediately, in evolutionary terms, they began to do something with it. The domestication of the olive tree, according to the strongest available archaeological and genomic evidence, occurred approximately 6,000 or 7,000 years ago, somewhere in the Levant that researchers continue to debate with increasing precision. What is clear is that by the 4th millennium BCE, the cultivated olive tree already existed as a species clearly differentiated from the wild olive, with larger fruit, higher oil content, and morphological characteristics that could only have been the result of deliberate selection over generations. The Phoenicians were the first major disseminators of the cultivated olive tree. Their trade routes throughout the Mediterranean, Carthage, Malta, Sicily, Sardinia, the coasts of Iberian Hispania, also served as routes for the dispersal of cultivated Olea europaea. At every point along the coast where the Phoenicians established a trading post, the olive tree arrived. And it arrived not as a subsistence crop, but as a commodity, as the raw material for an economy that functioned around olive oil in the same way that the modern economy functions around oil. Greece perfected what the Phoenicians had begun. The olive tree in Greek culture achieved a centrality unmatched by any other crop in the ancient world in the density of its symbolic meanings. It was the tree of Athena who had created it with a blow of her spear upon the rock of the Acropolis to win the patronage of the city that would bear her name. Olive oil anointed athletes at the Olympic Games, anointed the dead in funeral rites, fueled temple lamps, seasoned food, and served as the basis for the medical preparations described in remarkable detail in the Hippocratic Corpus. Hippocrates, in the 5th century BCE, mentions olive oil in dozens of prescriptions for skin conditions, digestive ailments, and wounds. Greek physicians were aware of its anti-inflammatory, emollient, and healing properties, though not in the molecular terms used by modern science. What they did know was the effect, that olive oil on an infected wound produced better results than leaving it untreated, that regularly ingested olive oil was associated with a lower incidence of the inflammatory diseases they saw in their patients, and that old olive oil, that which had partially oxidized during storage, had different properties than fresh oil. It was empirical knowledge. Its categorizations were imprecise, but it wasn't wrong. Rome inherited the Greek olive tree and transformed it into an infrastructure of power. The difference between the Greek and Roman attitudes toward the olive tree is, in essence, the difference between poetry and engineering. The Greeks loved the olive tree. The Romans managed it. And in that management lay the seed of what would happen in America 15 centuries later. The Roman agronomist Columella, who wrote the treatise De Re Rustica in the 1st century AD, still one of the most comprehensive texts on ancient agriculture available, describes with technical precision the best olive varieties for different soils and climates, pruning and harvesting techniques, methods for storing oil, and the organization of labor in olive groves. What can be read between the lines of Columella is an agricultural policy. The Roman olive tree was not just a crop, it was the plant that made conquered territories legible and manageable. A territory with olive groves arranged in rows was a territory integrated into the Roman economy. A territory without olive groves was still a wild territory, still outside the bounds of order. The Romans brought the olive tree to Hispania, to Baetica, which is now Andalusia, with the same efficiency with which they built aqueducts and roads. Roman Baetica became the empire's main producer of olive oil. Baetic olive amphorae have been found at archaeological sites from Scotland to Mesopotamia, giving an idea of the scale of the trade that the olive tree generated. The olive tree made Hispania an essential part of the Roman economic system, and this logic, the olive tree as a marker of integration into a broader civilizational order, is precisely the logic that Spain inherited from Rome when it began to build its own empire. The word civilization, in its Latin etymology, points to the city and the ways of life that the city implies. For the Romans, and later for the Spaniards of the 15th and 16th centuries, civilization had a diet. That diet included wheat bread, grape wine, and olive oil, not as an arbitrary cultural preference, but as markers of a Christian way of life, ordered, hierarchical. The trio of wheat, vine, and olive was not just food, it was theology, it was politics. It was the visible manifestation of what it meant to belong to the Christian Republic. When Spanish explorers and conquistadors arrived in the Caribbean and later the American continent, what they found, from that perspective, was a territory devoid of civilization. Not because the peoples who inhabited it lacked sophisticated political, economic, religious, and scientific systems. They had them, and in some cases more elaborate than their European counterparts of the same era. But because they did not cultivate wheat, make wine, or produce olive oil. The diagnosis was botanical rather than moral. The absence of the sacred trio was proof of barbarism. Correcting this barbarity necessarily involved introducing the trio. And the introduction of the trio, in the case of the olive tree, followed a logic worth examining in detail, because it has two sides that are symmetrically destructive. The first example is Peru. When Viceroy Francisco de Toledo arrived in the Viceroyalty of Peru in 1569 and began his systematic reorganization of Andean society in the so-called Indian reductions, his ordinances were not only administrative and religious, they were also botanical. The ordinances of Viceroy Toledo from 1570, which established the living and working conditions of the indigenous communities relocated to the new towns, included provisions on what could and could not be cultivated. Wheat, grapes, and olives were considered crops of the Republic, crops that marked the transition from the status of barbarian to that of Christian vassal. Andean crops that could not be assimilated into this category, and in particular those with ceremonial uses, were considered crops of idolatry, crops that kept their cultivators tied to the pre-Christian past. Quechua has a word for the plant that the conquistadors placed in the same category as the olive tree, but at the opposite extreme: cursed. Amaranth, which had been cultivated in the Andes as both food and a ritual plant for at least 4,000 years, was banned in many regions of the Viceroyalty of Peru precisely because it was part of the rituals that the evangelizers were trying to eradicate. The same thing happened with quinoa in some specific ceremonial contexts. Not in every case, and not with the same intensity in every region, but the logic was the same. The plants of the old gods were incompatible with the plant of the new god. The olive tree arrived in Peru in the second half of the 16th century. Oral tradition and colonial records attribute its introduction to Antonio de Rivera, a landowner who is said to have brought the first plants from Seville around 1560. Whether or not this attribution is accurate, what is certain is that by the end of the 16th century, olive groves were established in the coastal valleys of Peru, particularly in the Ica Valley, which possessed the dry climate and temperature conditions that olive trees need to thrive. These groves flourished, and their prosperity was not unrelated to the colonial policy that actively favored European crops over Andean crops. The history of the olive tree in Mexico has a second, equally revealing side, but with a different logic. While in Peru the olive tree arrived as part of a civilizing project, in Mexico it also became subject to a restriction that reveals something equally interesting about the mechanisms of colonial power. The olive tree arrived in Mexico relatively early. The first attempts at cultivation date back to the mid-16th century in the area around Mexico City and in regions of Michoacán and Jalisco with climates that could support it. And it worked. The 16th century Mexican olive tree produced both olives and oil. The local demand was real. The church needed oil for its ceremonies. Colonial cuisine demanded the oil that its chefs had consumed in Spain, and local production would have reduced the cost of importing oil from Andalusia. The Spanish crown responded with a prohibition. Not a total and explicit prohibition in all cases. Legal texts are more nuanced than popular narratives suggest, but rather a systematic policy of discouraging olive cultivation in the American colonies, which had a perfectly clear economic objective: to protect the Andalusian olive monopoly, one of the most important sources of income for the Iberian Peninsula. If the American colonists produced their own olive oil, exports from Seville and Cadiz would fall. If exports fell, Andalusian olive growers would lose income. If Andalusian olive growers lost income, the crown would lose revenue. The logic was perfectly clear to contemporaries, and documents in the Archive of the Indies in Seville contain complaints from colonial producers who fully understood that they were not allowed to cultivate what their soil could produce in order to protect producers in the metropolis. This policy, maintained with varying degrees of rigor throughout much of the colonial period, had a consequence that extended beyond economics. It instilled in the minds of the American colonial elites the equation between European and valuable, between what was their own and what was inferior. If good olive oil comes from Spain, then what grows here cannot be as good. If good wine comes from La Rioja, then the wine made here is the wine of the poor. And if truly medicinal plants come from the royal pharmacy of El Escorial, where Philip II had assembled the most complete collection of herbs in Europe, then the medicinal plants here are merely the work of Indians and superstitions. This epistemological shift from economic constraint to cultural contempt is one of the most effective and least visible mechanisms for the destruction of American medicinal knowledge. It didn't require bonfires. It didn't require explicit decrees against pre-Hispanic plants in every case. It was enough to establish, for generations, that what came from outside was civilized and what came from within was barbaric. For subsequent generations to internalize this judgment and stop passing on what their grandparents had known. Viceroy Toledo and his ordinances of 1570 are the best documented and clearest example of the explicit political dimension of this process. But the process continued far beyond Toledo, far beyond the 16th century, with the same logic operating through increasingly subtle mechanisms. The religious colleges that educated the indigenous elites, the College of Santa Cruz de Tlatelolco in Mexico, founded in 1536, being the most important, taught in Latin and Spanish, using European texts with references to Galen, Avicenna, and Dioscorides. They did not teach the knowledge that the Nahua commoners had accumulated over centuries. They taught the children of indigenous lords that legitimate knowledge came from Europe. The College of Santa Cruz produced extraordinary intellectual figures who translated classical texts and composed poetry in Latin. But it did not produce pharmacologists who systematized Nahua herbal medicine with the same rigor that European humanists applied to Greco-Roman herbal medicine. That knowledge remained in the markets, in backyards, among the healers whom the university-educated physicians of the 18th century regarded with a mixture of condescending curiosity and active contempt. In the Viceroyalty of Peru, the process took on its own variations. The extirpation of idolatries, the systematic campaigns to destroy Andean objects of worship and religious practices which the Church organized in successive waves from the 16th to the 18th centuries, included the destruction of what the extirpators called devil's herbs, medicinal and psychoactive plants that were part of the rituals used by Andean healers, the Kalawaya, and local medicine men in the diagnosis and treatment of illnesses. Some of these rituals were indeed incompatible with Catholicism in its colonial form, but the destruction did not distinguish between the ceremonial and the medical, between ritual and therapeutic use, because for the extirpators that distinction did not exist. Everything that was not European medicine was superstition, and all superstition was idolatry. The Kalawaya, the itinerant healers of the Andes who traveled the territory from Bolivia to Colombia, carrying their pharmacopoeia in woolen satchels, survived that pressure precisely because they were itinerant. They moved. They had no temples to burn or permanent objects of worship to confiscate. Their knowledge lived in memory and practice, not in buildings or idols. And that mobility saved them, though not entirely and not without cost. Meanwhile, the olive tree continued to grow. In the coastal valleys of Peru, on the haciendas of Ica and Arequipa, in the gardens of Lima's convents, in the cloisters of the religious orders that had been the first to introduce it. The olive tree grew because it was the plant that had institutional support, commercial backing, and the cultural prestige of being an Old World tree, a biblical tree, a Roman tree, a tree that Athens had consecrated and that the Gospel had mentioned and that Galen's physicians had prescribed. The Andean and Mesoamerican medicinal plants that the olive tree did not directly replace were displaced by the same system that favored the olive tree, a system that valued European knowledge over local knowledge, that protected the productions of the metropolis over the productions of the colony, that made the adoption of the conqueror's plants a marker of civilization and the retention of the conquered's plants a mark of barbarism. The result, after 3 centuries of botanical colonization, was a generational rupture in the transmission of American medicinal knowledge that was never fully repaired. Not total destruction, the herb markets of Tlacolula, La Paz, and Cusco are living proof that much survived, but a rupture nonetheless. A moment when entire generations of children of Nahua, Quechua, and Mayan healers and farmers decided, or were forced to decide, that the knowledge of their grandparents was too dangerous, too closely associated with what the priests called idolatry, too inferior to the knowledge coming from the university and the hospital to be passed on with the same pride and confidence with which it had been transmitted before. That rupture cannot be measured in numbers. There is no record of how many American medicinal plants ceased to be cultivated, how many preparations were forgotten, how many dosages were lost. But it can be estimated by absence, by the burned pages of the codices, by the irreparable chapters missing from Hernandez's edition, by the Nahuatl, Quechua, and Mayan names of plants that appear in colonial documents without a description of their use because the scribe who transcribed the name did not understand what they were used for, and the informant was no longer going to tell him. The olive tree did not order that destruction, but it was present throughout its duration, growing in the gardens of convents, shading the courtyards of haciendas, taking root in American soils with the quiet indifference of trees to the history of men waging war in their shade. And that image, the olive tree growing peacefully while what had grown before was destroyed around it, is the image with which the first half of this story closes, because it is the most accurate image of what botanical colonization means. Not the violence of the tree, but the silence of the tree about the violence that was exercised in its name. Oleocanthal is a molecule that chemists were not looking for when they found it. In 1993, researcher Gary Beauchamp of the Monell Chemical Senses Center in Philadelphia was testing a new extra virgin olive oil during a research trip to Sicily when he noticed something that no oil-tasting text accurately described. A specific irritation in the throat, a sensation that he, a pharmacologist by training as well as a sensory researcher, immediately recognized because it was exactly the same sensation produced by ibuprofen when taken as a pill and brushing against the throat as it goes down. It took Beauchamp 10 years to publish that finding. 10 years of laboratory work to isolate the compound responsible for that irritation, chemically characterize it, demonstrate that it was not an artifact of the tasting, but a real compound with real pharmacological activity, and finally published the results in the journal Nature in 2005 in an article that received the name of his discovery, Oleocanthal, from the Latin olea for olive and the Greek canthos for throat irritation. What Beauchamp and his colleagues demonstrated in that article is that oleocanthal inhibits cyclooxygenase 1 and 2 enzymes, exactly the same enzymes that ibuprofen inhibits, with a potency in vitro studies comparable to that of this synthetic anti-inflammatory drug. The mechanism of action is the same. The molecular target is the same. The difference is that ibuprofen was synthesized in a laboratory in the 1960s, patented by Boots Pure Drug Company, and became one of the world's best-selling painkillers, while oleocanthal has been present in extra virgin olive oil consumed in the Mediterranean basin for at least 3,000 years. 3,000 years of consumption of a natural anti-inflammatory whose activity was not molecularly characterized until the year 2005. That single figure, and the weight it carries when considered alongside the story we've told, could fill another entire video. But there's more, because oleocanthal isn't the only compound of pharmacological interest that the olive tree contains. Oleuropein is a phenolic glycoside that gives extra virgin olive oil its characteristic bitterness, a bitterness that consumers unfamiliar with quality oil sometimes interpret as a defect, when in reality it is a marker of phytochemical richness. Oleuropein has antioxidant, antibacterial, antiviral, and antihypertensive activity, documented in studies published in leading phytochemistry and pharmacology journals. Research by the Pharmaceutical Chemistry Group at the University of Granada, one of the European institutions with the highest scientific output in the field of medicinal olives, has characterized in detail the mechanisms by which oleuropein reduces blood pressure through the inhibition of angiotensin-converting enzyme, the same mechanism exploited by several of the world's most prescribed synthetic antihypertensives. Hydroxytyrosol is another polyphenol in olive oil that the European Food Safety Authority, EFSA, after reviewing the available scientific literature, included in its authorized health claims, recognizing that it contributes to the protection of blood lipids from oxidative damage. This is no small claim. The EFSA is one of the world's most demanding regulatory bodies in terms of evidence, and its authorized claims require a considerably higher level of scientific proof than most health products can provide. Olive leaves, not the oil itself, but the part of the plant most frequently used in traditional Mediterranean medicine for centuries, contain Oleuropein in significantly higher concentrations than the oil. Arabic folk medicine, documented with the same systematic approach by Ibn al-Baytar's 13th century texts as Hernandez documented American plants 2 centuries later, recorded the use of boiled olive leaves for fevers and infections. Ibn al-Baytar describes olive leaf decoction as a remedy for infected wounds and intermittent fevers, which we would now recognize as malaria, in a description that anticipates by almost 800 years what the phytochemistry laboratories at the Complutense University of Madrid have documented in the last 20 years regarding the activity of olive leaf extract against Plasmodium falciparum. Studies conducted at the University of Jaén and the Spanish National Research Council have also documented the activity of olive leaf extract against bacteria resistant to conventional antibiotics, including strains of methicillin-resistant Staphylococcus aureus, the bacteria known as MRSA, one of the most problematic agents of hospital infections, at concentrations that researchers describe as clinically relevant for topical application. We need to be precise here, precise and honest. In vitro activity, in cells and in laboratory culture plates, is not the same as clinical activity in humans. Studies on olive leaf extract and resistant bacteria have not yet completed the chain of evidence that would lead to an approved therapeutic application. Studies on Oleocanthal and its anti-inflammatory activity are extraordinarily promising, but they too have not yet produced a randomized clinical trial in humans with the methodological rigor that regulatory agencies would require for formal approval. This precision matters because one of the mechanisms by which herbal knowledge loses credibility is the exact opposite of what we described in the first part of this video. If before the problem was the institutional disdain for traditional knowledge, now the problem may be its enthusiastic exaggeration. Olive oil does not cure cancer. Olive leaf extract does not replace antibiotics. Oleocanthal is not ibuprofen in a bottle. These are compounds with documented biological activities that scientific research is characterizing with increasing rigor, and they deserve to be taken seriously precisely for that reason, for the strength of the evidence, not for the enthusiasm of those who promote them. What can be said with the available evidence is that regular consumption of extra virgin olive oil, with a high content of oleocanthal and hydroxytyrosol, which is the cold-pressed oil of olives harvested at their optimal ripeness, is associated in the largest available epidemiological studies on the Mediterranean diet with a statistically significant reduction in cardiovascular risk, the risk of some neurodegenerative diseases, and some types of cancer. The Mediterranean diet as a complete dietary pattern, not olive oil in isolation, was recognized by the United Nations Educational, Scientific, and Cultural Organization as an intangible cultural heritage of humanity in 2013, in part precisely because the scientific evidence on its health effects is among the strongest available for any dietary pattern from any region of the world. The PREDIMED study, Prevention with Mediterranean Diet, is the largest clinical trial to date on the effects of the Mediterranean diet on cardiovascular prevention. Coordinated by the University of Navarra and published in the New England Journal of Medicine in 2013, with over 7,000 participants in Spain and several years of follow-up, it demonstrated that a Mediterranean diet supplemented with extra virgin olive oil or nuts significantly reduced the risk of major cardiovascular events compared to a low-fat diet. The risk reduction in the group consuming extra virgin olive oil was approximately 30%. This figure is clinically relevant in the context of preventive cardiology. That figure, 30% reduction in cardiovascular risk with extra virgin olive oil, is the number with which the history of the olive tree finds its own place, because it is the number that demonstrates that the tree that arrived in America as a weapon of cultural colonization is also, in its own terms, a first-class medicinal plant with a scientific basis that no contemporary pharmacologist can ignore. And here lies the central paradox of this story, the paradox that makes this video something other than a simple denunciation. The olive tree is not guilty of having been used as a tool of domination. Oleocanthal has no political intentions. The olive leaves that Ibn al-Baytar prescribed in Malaga in the 13th century for fevers are the same leaves that grow today in the olive groves of Ica in Peru, in the very valleys where Viceroy Toledo promulgated the ordinances that attempted to suppress Andean knowledge. The question that remains open, the question we posed at the beginning and which we can now answer with more nuance than we had at the start, is, can a plant be colonialist? The answer is no. Plants cannot be colonialist because they lack political agency. But the people who move them from one continent to another, who decide what grows and what doesn't, who protect some crops and suppress others, who use botany as a language of power and exclusion, those people can act in a colonialist manner. And that is precisely what happened. The olive tree was an instrument. An extraordinarily effective instrument because it was beautiful, because it was ancient, because it produced something genuinely valuable, because it had the backing of Athens and Rome and the Bible and Galenic medicine and the royal pharmacy of Philip II. No instrument of power works as well as one that has legitimate reasons for existing. The mistake was not in bringing the olive tree. The mistake was in bringing it instead of local knowledge, instead of alongside it. In bringing it as a replacement, not as an addition. If, back in the 16th and 17th centuries, someone had had the vision and the intellectual honesty to say that olive oil and Sacha Inchi oil each have their own specific properties and medicinal uses, and that both can coexist and enrich each other, the history of American pharmacology would have been different. If someone had been honest enough to say that olive leaves and Andean Munya leaves can compete with each other in the market without either needing to be banned for the other to thrive, the next 3 centuries would have produced a wealth of accumulated medical knowledge that would be immeasurably richer today. This is where this story becomes a conversation about the present, and this is where I want you to stay a moment longer. If these intersections between history and plant science are what make you think, subscribe to the channel, because every week we open an archive that someone would prefer to keep closed, and there are several ongoing stories that are just as complex and urgent as this one. The olive tree's presence in the Americas today far surpasses what Viceroy Toledo could have imagined. The olive groves of Ica in Peru produce oil exported to markets worldwide. The olive groves of Mendoza and La Rioja in Argentina are part of a growing industry producing oils of comparable quality to the best from Andalusia. The olive groves of Chile's Central Valleys, Maule, O'Higgins, and the Biobío region have flourished in recent decades with varieties introduced from Spain and Italy. The olive tree stayed. It naturalized. It became as integral to the landscape, economy, and cuisine of South America as it had been to the landscape and economy of Andalusia 16 centuries earlier. That doesn't erase what happened, but it also doesn't mean that the history of the olive tree in the Americas is only a story of loss. It's also a story of transformation, of a tree that arrived as a symbol of domination and ended up becoming part of the cultural identities of the very peoples over whom that domination was exercised. The olives cured in Lima's markets with salt and yellow chili peppers are not the olives served at Augustus's banquets. They are something different, something that exists only because 2 traditions met in one place and transformed each other, even though that encounter was profoundly unequal and deeply violent in many aspects. How should we cultivate olive trees today, given this context? The practical answer is, with awareness and precision. The olive tree is a long-lived tree. It can live for 1,000 years under suitable conditions, and some specimens in Andalusia, Greece, and Tunisia have documented or estimated ages exceeding 2,000 years. For home or semi-professional cultivation, the varieties that produce oil with the highest oleocanthal content are Picual, Hojiblanca, and Arbequina, according to the classification of the best olive growers by the International Olive Council. The olive tree requires cool winters to enter dormancy, dry springs for efficient pollination, hot summers for fruit ripening, and well-drained soils. It tolerates drought with extraordinary resistance once established, but needs regular irrigation in its first few years. The highest quality oil for pharmaceutical purposes is cold-pressed, extra virgin olive oil, obtained from olives harvested when they have reached veraison, the point at which the olive changes from green to purple, but before it has completely darkened. At this point, the oleocanthal content is at its peak. As the olive ripens and darkens, the oleocanthal content decreases, and the resulting oil is milder and less bitter, but pharmacologically less active. For medicinal use, the most common preparation of olive leaf is an infusion of dried leaves, between 5 and 10 grams per liter of water, consumed in 2 to 3 cups daily for traditional uses related to blood pressure and minor infections. Known contraindications include interaction with prescribed antihypertensive medications, with which olive leaf extract may have an additive effect that produces hypotension. People taking these medications should consult their doctor before using the extract regularly. Use during pregnancy and breastfeeding is not sufficiently studied, and caution is advised. Correct identification of olive leaf presents no risk of confusion in most Spanish-speaking regions, but in areas where oleander or garden bay, Nerium oleander, grows wild or cultivated, the difference between the leaves of the 2 species should be known. Oleander leaf is toxic and superficially similar to olive leaf, although with a different texture and vein pattern that a careful observer can easily distinguish. Olive seeds, crushed olive pits, are used in some regenerative agriculture programs as a high-quality composting substrate. Pumice, the solid residue left after pressing, has applications in animal feed and biomass generation. The olive tree, like all large Mediterranean trees, is an ecosystem in itself. Its branches support lichens, fungi, insects, and birds that live in no other habitat, and traditional olive groves with high biodiversity density, that is, extensive olive groves, not modern intensive irrigated olive groves, are recognized by the Convention on Biological Diversity as one of the agro-ecosystems with the greatest conservation value in the Mediterranean. Share this story with someone who thinks botany is a neutral science. And subscribe, because we don't tell neutral stories about plants here, we tell true stories about what trees and empires do together when no one's watching. Trees have no homeland. They have no flag, no royal decree, no viceroyalty. The olive tree that grew in the courtyard of a colonial hacienda in Ica didn't know it was in America. The olive tree that shades a town square in Cajamarca today doesn't know it arrived on that soil on the wrong ship. But its roots are now so intertwined with that soil, so deeply embedded in that substrate that was once Andean and is now also Mediterranean, that separating it would no longer be possible without causing harm. That's what history does to plants. It makes them inseparable from the places where they took root, regardless of how they got there. The work that remains, the work that belongs to us, not the tree, is to ensure that the plants displaced by the olive tree also find their place in that soil. Not in place of the olive tree, alongside it.